All right, let's just jump right in, because today we are wrestling with, well, one of the biggest questions you can even ask. What is matter? I mean, really, what is it? We all think of it as, this solid fundamental stuff, but what if it isn't? What if it's something else entirely, something more like a stable illusion built from, and this is the crazy part, literally nothing?
So let's just, right off the bat, mess with our intuition a little bit. Ask yourself, what's an electron? Seriously, you're probably picturing a tiny little ball, right? A fundamental thing zipping around. But there's this radical new framework, it's called CRET, that says, nope. CRET stands for Constraint-Resonance Emergence Theory. Bit of a mouthful, I know, but the core idea is that what we call a particle isn't a thing at all. It's a pattern, a persistent, stable pattern that bubbles up out of a much, much deeper reality.
Okay, to really get our heads around this, you have to throw out the old way of thinking. Forget looking for one single foundation of reality. Instead, I want you to picture it in 3 distinct layers. The best way to think about it, honestly, a video game. You've got the raw code, right? The ones and zeros. Then there's the game engine that takes that code and builds rules out of it. And then you've got the actual world you see and run around in. Well, this new idea suggests that physics works in pretty much the exact same way.
So let's actually break this architecture down. At the very bottom, you've got the micro layer. This is just pure chaos. Think of it like a buzzing sea of information, of fields or qubits just flipping like crazy. It's the basic ones and zeros of reality. Now, one level up, you get the meso layer. This is your game engine. It takes all that chaos from below and starts organizing it. It weaves it into structured patterns, what physicists sometimes call string nets. And then, at the very top, you have the macro layer. This is the big boss. It imposes the rules of the game from the top down. The big, unbreakable laws like conservation of energy. It's what keeps the whole system in check.
All right, so we've got our layers, you've got chaos at the bottom, an engine in the middle, and rules at the top. But where's the particle in all this? How does something that seems solid and stable just pop into existence? Well, it's not automatic, that's for sure. It takes a very specific process, a kind of feedback loop between these layers. It's like a recipe for making matter. So let's take a look at that recipe. So what we have here is this amazing 3-step dance. First, you get what's called upward amplification. Down in that chaotic microlayer, little random flickers start to team up. They cohere into these little lumps that can move around. But most of them just fizzle out. That's where step 2 comes in. Downward selection. The big rules from the macro layer, they push back. They act like a filter, basically saying, nope, you can't exist. You, however, you have the right properties, like a conserved charge, you get to stick around. And then, step 3. This is the magic. It's called resonance. It's that perfect moment when the lump pushing up from below and the rule pushing down from above just click. They lock into place. And when that resonance happens, the pattern crosses this incredible line. It's called the autonomy threshold. This is it. This is the exact moment a particle is born. The pattern becomes so stable, so self-sufficient, that it kind of forgets where it came from. It completely decouples from all that chaos in the microlayer. And suddenly, boom, it has its own rules, it has a mass, it has a charge, it starts acting like an independent, standalone thing in the world.
Okay, I know what you're probably thinking right now. This is cool, as a story. It sounds like some really out there philosophy, or maybe science fiction. But is there any reason to think this actually happens in the real world? And the answer, which is kind of mind-blowing, is yes. Absolutely. We can actually see this exact kind of process happening right now in our labs.
Yeah, you heard that right. We already see versions of this in the lab. This isn't just some wild idea a theorist dreamed up. The fundamental principle here, that you can get stable, particle-like behavior to emerge from a big, messy system as long as you get that feedback loop to lock in. That's a real, observable thing.
So in the world of condensed matter physics, they see these things all the time. They're called quasi-particles. And they're not real fundamental particles, they're emergent patterns that act exactly like particles. It's wild. For instance, they found excitations in materials that carry a fraction of an electron's charge. How is that even possible? Or they'll see things that behave just like photons, like particles of light, pop up in these weird magnetic materials called spin liquids. Even something as basic as an electron's mass, it's different inside a chunk of metal than it is in a vacuum. Why? Because it's an emergent property of the whole system. These are all real-world proofs that this idea works.
Okay, so we've established the principle is sound. It happens, we see it inside of materials. Now we get to the really fun part. This is where we take that established science and we make a huge speculative leap. This is what CRET is really all about, asking a much, much bigger question.
And here is the absolute heart of it. On the one hand, we have the established science. It's a fact. In certain materials, these things called quasi-particles emerge from a collective system. We know this. But on the other hand, here's a giant leap. What if the fundamental particles that make up you and me and everything else, the electrons, the quarks, the photons, what if they are also just emergent patterns? What if the vacuum of space itself is the material, and our entire reality is just the quasi-particle?
And the amazing thing is, this isn't just navel-gazing. It leads to real predictions we could actually go out and test. For example, the theory suggests that if you could somehow tune the fundamental properties of the universe's vacuum, turn some cosmic knob, you could actually trigger a phase change and alter the mass of an electron. It even predicts that something as sacred as Einstein's relativity might not be a fundamental law at all, but just an emergent property that happens because our universe is balanced on this perfect razor's edge of resonance. This is what makes it real science. You can come up with ways to prove it wrong.
And that leaves us with one final absolutely mind-bending thought to chew on. If matter isn't a fundamental thing, if it really is just a stable, resonant pattern, then all those properties we think of as fixed and unchangeable, mass, charge, spin, they might not be so fixed after all. Which leads to the ultimate question, doesn't it? If we could one day learn the rules of this deeper game, could we learn how to intervene? Could we change the pattern? Could we, literally, reprogram reality itself?